Hello, today we're going to look at solving inequalities, and the first thing we need to do is look at the vocabulary that is involved and the symbols. When you see this symbol, many of you are already familiar with that. It means less than. We can also see it represented in spoken or written as fewer than. Now, one that you have probably seen before but don't remember is this right here that's less than or equal to. And notice we have the less than symbol, but we also have the equals symbol that goes underneath right there. That can also be seen, written or spoken, as no more than or at most. The next one that is very familiar is going to be greater than. You've seen that. It can be seen also as more than. And then finally, the last symbol, again, this is one that you have seen but probably don't really remember much about, is the greater than or equal to. It has the greater than symbol, and then it has the equal to sign underneath. And that means no less than or at least. And let me show you how we will represent these on a number line. Less than, we will put in an open circle. For less than or equal to, in fact, anything that has an equal to sign, we're going to start with the open circle and then fill it in so that it's a dot. Okay, there's a dot. Greater than is an open circle, and greater than or equal to, because it has the extra part, we're going to make our circle and then the extra filling in. Now that's when we start our number lines. I just want to introduce that to you. Right now we're going to look at solving, and if you remember, solving with an equal sign, this is almost the same. There are a couple of exceptions. On number one, I can draw my line just like I normally would. I don't have a constant, but I do have a coefficient, and when we have a coefficient, we divide by the coefficient. And I end up with x is greater than or equal to 6. So I'm going to come over here and start at 6, 5, 4, 7, 8, 9. So remember, if it has the equal sign, then we're going to put a dot and fill it in, a circle and fill it in. And then we're going to go in the area that it points. Now this points to the right, so my line I'm going to draw in will point to the right, and since I don't have an endpoint listed, which we'll get to in a later lesson, I'm going to draw an arrow on it. Alright, number 2. This one I do have a constant, so in order to get rid of my constant I need to subtract, and let me stop right here for just a moment. One of the tricks that I try to teach is if this does not have an x and there's nothing over here, I want to come over here and write it in a different area, not underneath the x. And then I have 3x is less than or equal to 2x minus 8. Now I need to move my 2x. I should have done that first actually. So since it's positive, I'm going to subtract it. There's no harm, no foul right here. So 3x minus 2x gives me just x is less than or equal to. These cancel out, not the negative, and I must bring down the negative 8. So I'm going to come up here. This will be my negative 8, negative 7, negative 6, negative 9, negative 10. Alright, so I have the equal sign, so I'm going to use the circle and fill it in. And then I'm going to go in the area of in the direction of my inequality. Alright, now's a good time to talk about what does it mean when I fill this in. It means that part of my solution can be -8. It could be -9, could be -10, could be any of the points in between. On number 1, what it means here, the dot is on number 6. That means 6 could be a solution to the inequality. All right. Number 3. So we're going to add or subtract the constant. Then we'll divide by the coefficient. And we get x is less than -4. Oh, -4, not 14. Alright, so I'll put my -4 right here. -5, -6. Come over here on this side, -3, -2. Alright, so I do not have the equal sign, so I'm going to put just an open circle, and then I'm going to go in the direction of my inequality. It's pointing to the left, so I'm going to the left, and I'm going to put an arrow. So let's talk about what does it mean when we have an open circle. That means that -4 cannot be a solution, but everything to the left of it can be. So the circle means it cannot be, but everything in one direction or the other will work. Alright, let's try this. We're going to add or subtract the constant. Remember, whenever you see those little negative signs, sometimes it's good to bring down an arrow just so we know that we have to keep it. So 22 minus 7 is 15. Now here's one of the changes. Whenever you divide or multiply by a negative number, your sign must change. Very important. Whenever you divide or multiply by a negative number, your sign must change. So when I'm dividing by my coefficient is -3. My coefficient is -3, and I am dividing by -3. This greater than part must change to a less than or equal to part. Alright, so this now becomes x is less than or equal to 15 divided by -3 is -5. Again, I need to stress to you, this is the one big change from the way you've done things in the past. If you multiply or divide by a negative number, you must change your sign. Notice we started with a greater than or equal to. We divided by a negative number. It is now a less than or equal to. Okay, I'm going to put my -5, -4, -3. Just fill out my sign here. I have the equal sign, so I'm going to put a dot and fill it in. And then I'm going to look at the direction and draw my line and put my arrow. Fill in my arrow so it's kind of neat, not very neat. Alright, number 5. Just like normal equations, we're going to combine like terms. And here I have a plus 6x minus 2x. That will give me a 4x. Bring down my 10, it's positive, is greater than 50. eliminate my constant. I end up with 4x is greater than 40. Divide by my coefficient. X is greater than 10. I do not have the equal sign, so I simply draw an open circle and I follow the direction that it points, which is to the right. There we go. Here, I must make my distributive box. I'm going to come over here and do my Punnett square. I have negative 2 times x plus 3. That gives me negative 2x minus 6. So this becomes negative 2x minus 6 is greater than negative 22. I'm going to add or subtract my constant. I end up with negative 2x is greater than negative 16. I am dividing by a negative number. I am dividing by a negative number. The coefficient of x in this case is negative 2. I divide by that coefficient, so I must, at this point, change my sign. I get x is now less than 8. I don't have an equal sign, it's just the less than. So I put an open circle, and then I make my line in the direction that it points. And put my arrow. If you're not putting your arrow on, you are not doing this correctly. Alright, we don't have a constant, but we do have a coefficient. So I can divide by my coefficient. I'm going to divide by 2/3. 2/3. Divide by 2/3. And remember, if you're dividing, you can flip your fraction and multiply. I end up with 30 over 2, which is the same as 15. So I have x is greater than 15. No equal sign, it's an open line. Follow the direction of the sign, put in my arrow. Alright, on this, I'm going to move all of my variables to one side. I find which is the greater and which is the lesser. 6 is greater than negative 2x. So always move the one that is lesser. So I'm going to add 2x to both sides. I get 9 is less than or equal to 6x, and 2x is 8x minus 15. Now I'm going to move my constant at 8x, and I get 24. Now I divide by my coefficient. And I get this. Well, the only way I can make this work with the rules that I have is to change this around. So notice this opens towards the x. So if I were to change this around, I put my x on the left side, I would have to have it still open to the x and then put it that way. So notice, to change it so that I can write this in my equation properly, I need my x, or my variable, on the left. I looked at this. I saw this opens to the x. When I wrote this, I wrote it so that it opens to the x. Now I know that x is, oh, I forgot my equal sign. I just noticed that. It was in the original, so I need to put it here. X is greater than or equal to 3. So since it has an equal sign, we fill it in. And voila. So I'm looking at a positive 3x, a negative x. The lesser is the negative x, so I'm going to move that one. And there's a very good reason we move the lesser. It's because it keeps us from having to do a lot of negative numbers. And after teaching math for quite a few years, I realized that the more we can avoid the negatives for x, am I doing this right? For x is greater than or equal to 6, and so that means we divide by 4 for x is greater than or equal to 1.5. Okay, very interesting. So what I'm going to do, 1, 2, 3, I'm going to put in a 1.5 here, and since I have the equal sign, it becomes a dot. It's pointing towards the right. I go to the right. Alright, notice this says do not solve. Fred the farmer has started a savings account for a tractor. He has saved $600 last month, plans to add $100 each month. Well, anytime you see each or per, you know you need to start multiplying. So our variable in this situation is going to be maybe m for months. Oh, look at that down here. And until he has saved more than 2,000. Well, more than tells me I need to use this. More than 2,000. I start off with an initial amount of 600 plus 100 times months. Gabby the Gabber likes to text message to her friends using her cell phone. She is charged 10 cents each. I need to multiply. Each time she types a message, plus $50 for the phone plan. So this is going to be each message. So here we go. M for message. She has to have something that is at most. So I look at this. At most, I must use this sign. This means at most. It could be 60, and it can be less. So we have a one-time fee of $50 plus 10 cents or 0.1 times the number of messages.